I'm Young Lee, a drama therapist and also the moderator of today's forum. So today we have two keynote speakers, the concept artist Wong, or I know him as Young, and also the creative technologist Markus Lanxinger. So first, Young will talk about how he developed this artwork, Auguries of Innocence, and how he explored virtual and creative coding technology through the collaboration with Markus. And then we will pass to Markus. He will talk about how he transformed and explored the ideas from Young and collaborates with him to develop the artwork. So previously, I worked with Young on another project on arts and mental health awareness. So I know Young is an artist curator who loves to collaborate with people from different disciplines and also take these opportunities to explore and exchange and promote cross-disciplinary collaborations. So last year, we collaborated and presented a number of feature articles on mental health awareness among the creative community in Hong Kong. So I'm very excited to see and know how Young continues his artistic ventures to explore and develop new collaboration with markets and to create contemplative artwork in virtual world. So today, Young and Markus will share their keynotes about 20 minutes each, and then we will have a Q&A session. And during the sharing, if you have any question, you can write down in the chat box or in Facebook. And now we are doing Facebook Live, so you can also see us on Facebook. And I'll gather the questions and also ask the speakers. And you can also ask them during the Q&A session yourself. Let me pass to Young.
Thank you. Hello everyone, welcome to this forum in between two realms, the making of auguries of innocence. My name is Wong. I am the concept artist of this virtual artwork. In this forum, I will share the artistic aspect of this artwork, how I create this contemplative art through the collaboration with creative technologist Markus Lanxinger. And then I will pass to Markus. He will share the technical aspect of the artwork, how he implements my artistic idea with creative coding technology. You can look at our presentations as a colloquium that offers a case study about the symbiotic relationship between artists and technologists. Why do we need to explore cross-disciplinary collaboration? Let me introduce myself before we start. I am an installation artist and an artist curator. I base both in Zurich and in Hong Kong. My artistic practice involves making experiential installations, producing cross-disciplinary programs, curating cultural exchange programs, and hosting educational workshops. Let me share a 1-minute trailer, which is also the conceptual reference for the creative team to develop their inputs. It gives you an idea how we started our collaboration. Now let me share the key information about this artwork. Auguries of Innocence is a visual album. It is the 4th chapter of my contemplative installation series. So in this visual album, I combine visual and audio elements so that you can listen or watch it like going to YouTube or Spotify. To enjoy the artistic content, this project, it is also a continuous artistic response toward my research on mindfulness and contemplative space, which is also the core concept of the project. For this particular artwork, it is also the first online artwork I directed. I combined these two concepts with virtual reality and coding technology, so that in this project I can explore the artistic possibility with creative technologists. For this artwork, I was aiming at creating a hybrid between virtual art and installation art. I envisioned this artwork is like an abstract animation. It gives us an audiovisual experience with a conceptual narrative. And this conceptual narrative is about finding solace in grief, which is inspired by my personal experience from a family member who passed away from cancer. I want to use this artwork to allow the viewer to immerse themselves into this abstract experience so that they can quietly observe and be curious what is presented in front of us. You can go to the LCSD website to check out my Artist Talk series, taught in 3 parts, in which you can learn more about the concept, the background, and the history of this artwork. But today I want to focus on sharing how I approached this cross-disciplinary exploration between contemplative art and creative coding, and how our collaboration inspired this artwork. Interestingly, it actually happened very unexpectedly. Last year, I was presenting my experiential installation in the HKAPA, A Heaven in a Wildflower, which is also the previous chapter of my contemplative installation series. And Markus was filming the 360 VR video for the school, and this was also the first time I came across the VR technology. And since we both like exchanging ideas between art and technology, I then shared with him the concept and the ideas of my installations. I shared how I developed these physical installations from my research on mindfulness and contemplative art. Markus then suggests the possibility with these new creative technologies, such as using creative coding to transform physical art into online virtual art. And then our brainstorm and exchange brought in new inspirations. Our conversations inspired me to experiment on how to create contemplative space in the digital world. Later, I asked him to join this project as the creative technologist so that we can experiment with our ideas and turn them into actions. And this is how this artwork was born. 2 enthusiastic people from 2 different disciplines, just sharing and incubating ideas. And then very quickly, Markus suggested that we can use WebGL, this kind of API, application programming interface technology, to use into our artwork. So for those who are not familiar, what is API? API is the interface that acts as the middleman to ensure 2 applications or 2 computers talk to each other. Later in the presentation, Markus will explain in details how we use WebGL to communicate, the code we developed and store in the server, and how we execute all the 3D models, effects, 4K textures, light and physics, and camera movements without downloading any software to render these animations real-time in our browser. And later in our concept development, we decided to use this WebGL technology to create immersive virtual experience without any VR device. For those who are not familiar with WebGL, WebGL is short for Web Graphics Library. It is a JavaScript API technology for rendering interactive 2D and 3D graphics within any compatible web browser without the use of any plugins or any additional software. Which means you do not have to install anything, you do not have to download anything, then it executes directly in your web browser. Here is a 1-minute video created by Fireship. You can go to their YouTube channel to check it out. Later, we decided to experiment with this technology, and we started to infuse his technological ideas and my artistic ideas together to create this artwork. And we want to see what kind of hybrid we could come up with. We began with these simple questions. What we could benefit from virtual reality and creative coding, and what would be impossible to create in physical space, but now we can do it in virtual reality. I then came up with this approach and then shared with him. I told Markus I imagined that I was directing a performance or creating a stage design in this virtual reality. And in this virtual reality is about giving an abstract audio-visual experience. And it is similar to one of those immersive computer games. It's about being in the virtual world to immerse yourself into a conceptual narrative as you play along. It is not about winning or losing. It's about being in it and enjoying the process. And later when we carry on, we want to experiment with the artistic and technological aspects. We want to challenge ourselves to use this technology to create a cinematic immersive experience that comes with highly detailed 3D models and realistic 4K textures. To achieve this realistic texture, just one stone is about 1 million polygons, and then we optimize it, but at the end it's still over 15,000 polygons. But this approach is actually very different from the past, because online art in the past were very restricted to apply simple 3D model with no to very simple texture mapping, because they have to keep the data traffic as minimum as possible for the browser to process and create real-time response. But our approach with very realistic details and strong cinematic narrative directly challenge us how far we can push with our creative coding. Because our heavy coding will force the computers and the servers to execute real-time 4K video output without any software installation. This is actually very challenging to execute in an internet browser. After 2 months of development, we finally launched this artwork, and we realized our experiment is new to many of us. We even surprised ourselves that we could push this technology to create such an audio-visual experience with high resolution output through just an internet browser. Before I finish, let me conclude. This technology is still growing and it is full of new possibility for visual and performing arts. This technology has already had a huge community online, and they are creating thousands of content in their online library, and they open for everyone to use them. All you need is to link them up by internet. Before I pass to Markus, remember, no matter if you are an educator, a student, or a commissioner, you can look at my sharing as a case study of a symbiotic relationship between artists and technologists. We can reflect on this question: why do we need to explore cross-disciplinary collaboration, and how a cross-disciplinary collaboration influences new development for art, technology, and education. Please visit our website to check out the other projects. If you have any questions, we can discuss in the Q&A session. Now I pass to Markus. Thank you.
So thanks for having me. I'm going to try my best to give a very rough technical overview of all the technologies involved and how we, as a team, transformed Qingyong's vision for this artwork, given the most recent technology into this interactive browser experience. So it's just a small intro about myself and background and my mission, then an intro of the team that worked on it on my end. It's a general overview of the production pipeline we used on this, so all the technology involved and in what steps they were done. And then we sort of do a deeper dive into real-time 3D web technology, into WebGL, FreeGS, and associated technologies. Like Jiyoung already explained a little bit about it. And then at the end of it all, we can do Q&A. So this is a little bit about myself. So I'm a creative technologist. I have a background in filmmaking and computer science, and then worked for many, many years on Hollywood films, big blockbuster movies, and sort of on the visual effects department, and also on set, sort of supervising the stereoscopic filming. And then subsequently sort of moved more in the technology part again, and then I worked for a technology company that was producing cameras where you could film things in real time using actual video, and then display it in a 360-degree sphere inside of a virtual reality headset. And after that, based on all my sort of past experience, I founded sort of my own company, and then was applying this knowledge in the art world and helping artists to sort of translate their work into the digital space, while also sort of reducing a carbon footprint by a lot of the artwork shipped around the world. So yeah, just a little background about the sort of visions. There's like two arms. One is a sort of development for software that makes the display of art easier, which you sort of see on the right. So it transforms a series of images into sort of a 3D model using a process called photogrammetry. Then we optimize these models, and then I display them in different sort of ways. As you see here is virtual reality is one, augmented reality, or WebGL technology is one of them as well. So the advantage of that is, of course, as we see now in these times, especially where we physically cannot be in certain places, that we can sort of render that realism as good as possible on two people's end devices, which these days have quite powerful CPUs and GPUs. COVID has certainly accelerated this movement into the digital space. And also about my team. So one is Guillaume Ferdin, worked in films for visual effects for quite a long time, and he's also a filmmaker, and he also developed FreeGS and WebGL technology with a tool called PolygonJS, which he open sources, which means it's publicly accessible source code for everyone. And then a 3D artist named Dusan Saric, who's also has about 7 years experience, and he's like a generalist, which means he has experience in like pretty much all areas of the 3D pipeline, which goes from modeling to texturing to lighting to rendering. So that's and also in photogrammetry, which is what a lot of the assets we are using. So here's a general sort of overview of a general production pipeline, which is did some modeling, which we did in Blender. Then we built the environment, so we arranged all the different elements together. Then we sculpt some details and we retopologize, which means we reduce the amount of triangles. Then we texture it, bake light maps, which is basically the lighting that we set up inside of a 3D virtual environment. We we bake those on top of the textures, so they are part of the textures. Then we optimize these textures through compression technology, and then we have to export them into a format that is also like an open format for the 3D web, which is called GLTF, which is basically a binary format that packages 3D model data and textures into one single file, and then you can then render that model back on WebGL for virtual reality. So next, we're going to look at modeling, sort of how we built the environment inside of Blender. We assemble the scene, we sculpt on some details, then we apply the textures, and we add some lighting to it. So in the beginning, we start off with like very simple objects, right? As you can see here, just like a torus, and then basically what we do to this is, so it's a very simple geometry, and we do a process called subdivision, which basically means we divide the triangles into sub-triangles, and then adding more detail to a certain amount of triangles. So less amount of triangles basically means less amount of details. After we've done this, we bring in photo-scanned realistic assets, which are from rock formations, which have been obtained with photogrammetry, and we place them in the 3D scene, as you see. So we bring them in, and those are usually in FBX or OBJ formats, so which is also another modeling format. And then you can scale them, rotate them, position them as the way you want it. You can layer them up, build and replicate the artist's vision as good as possible in sort of this 3D environment. Yeah. So this is as you can see, this is a very long and tedious process. And after we've sort of done the arrangements, then we have to combine them into this environment to sort of make up the stage. And then we, at last, we apply the lighting with different colors, different shapes of lights to sort of set the mood for the scene. So after we've built the environment, at that point, we were probably at 20 million polygons, which is way too much to a web browser. So we basically went to decimate, which is basically reducing these polygons while retaining a lot of detail and texture quality. Then we basically have to combine and pack these UV maps. UV basically like XY coordinates of like triangles on the texture map to map the triangles onto a flat surface. So we started off with 8K maps, and then we have to combine them down into 4K maps. Next, we're going to look at the real-time 3D web technology we used. WebGL means that it basically allows you to render 2D and 3D elements in a web browser on an HTML canvas without plugin. Consists of code written in JavaScript and GLSL, which stands for GL shading language. So it's basically shaders that are executed on a graphical processing unit. And the big advantage of this is you can sort of combine it with traditional HTML, hypertext markup language. So you can integrate that in standard sort of websites. Then shaders, so basically we've already seen a small overview. Shading generally did is to replicate light, darkness, and render them. In our case, we post-process a man to make it seem like he's emitting light, or we have a water shader that's sort of that's using a simulation of like how in reality waves would be formed, and lighting would interact with it in real time and the reflections on it. And then another important technology we have to use is compression of the meshes. So basically, we even when we compress them down to, let's say, like 300,000 triangles, that's still quite a lot of triangles for a web browser. So Google developed a technology called Draco Mesh Compression and open sourced this technology for everyone to use. So it's inside of Blender, it's inside of FreeJS and all these different tools we used. And just to get a basic idea of what it looks like, I'm going to play this very simple video here. It's basically allowing us to render the model at up to like 10 times so it can display a lot more triangles in a very short amount of time. Next, I'm going to talk about FreeJS a little bit and why it's great. So yeah, first of all, it's open source, which means we can very easily look at the source code, look at examples. There's active community development on it. There's quite a lot of different effects that people have developed and are contributing to the open source platform. And then you can go in and basically use them, iterate on very high-end sort of 3D environments. So here's sort of a sample of a very, very basic FreeJS scene. So this follows just basic JavaScript. So you create a scene, and then you create a camera, and then you render this GL renderer, and then you create a geometry, in this case a box geometry, so it's a very simple cube, and then you apply material, and then you sort of add this cube to the scene, and then you can basically see a simple cube. In this case, it's a green cube that comes out of this code. So it's, as you can see, is a very basic version, and it requires just this few lines of code just to display just the green cube. But what you wouldn't believe is that behind each of this is actually a lot of code in the background that's been developed. And that brings us to Polygon.js, which is making this even easier. So it's node-based. That means you can sort of plug into, you can sort of have a graphic sort of development environment. And you can have different kind of nodes that serve different kind of purposes. It makes development a bit easier and iteration a bit faster on certain things. So this is what that looks like, just to give you a simple idea. So here we have sort of a WebGL viewport on that scene. And on the right, you see all these nodes. And you can see different sort of relationships between the nodes. So if a sky environment map, which is basically a sort of 360-degree map in the background. And you can see it here in action, actually, with the reflection and everything in real time. So this is almost like an attempt of making FreeJS be sort of interactive in the web browser and almost behave like a game engine would work, but in a web browser. Last but not least, I want to go through some of the challenges we faced. So as you've seen in this, the scenes are quite complex. So we're incorporating a lot of elements of photogrammetry, which are 3D scanned assets. So they're created using hundreds of photos and then run through its whole sort of own pipeline and optimization. So that's already, up to like 10 to 20 hours of work per each element. After that, we have to go for optimization. So between the environment building with compression, texture compression, and everything, we spent about 200 hours on that. And then it goes to coding, and then after all that was done, there was a lot of tweaks and troubleshooting and testing, and then we find that browser support is still sort of lackluster, and then also older computers are not very well supported since they have no dedicated GPUs. And then WebGL itself is just the beginning of sort of the interactive web technology. So there's an upcoming technology called WebGPU that's about 10 times more performant than what we currently have. So, which means what you're currently seeing with the same hardware, you'll get 10 times better performance. So what we sort of developed, which is photorealistic elements, you can see it even with computers from 5 years ago, which currently is not possible. So those are all things that are very much under development, and probably takes still a few years until we get there. But that's basically it from my end. So you can email me if you have any questions on my email, markus@lightfield.industries, or you can follow me on the website, or you can also follow me on Twitter. Yeah, thank you very much.
Let me start to kick off the Q&A session first. And is there any tips or advice you would give for future exploration on maybe transforming physical artistic project into virtual one, or having this collaboration between artists and technologists?
In a browser-based 3D interactions or browser-based virtual reality is not something new, but we are at the edge of having a new huge revolution because CPUs and GPUs are getting so fast. In terms of the artistic value or creative value, you can see it will become a huge impact on film industry or animation industry or artistic industry. Because in the past, you still have to go to the cinema to see an animation, but what is going on or what is going to be in the future is it would be all you need is just go to a website or you put on your VR device, you will be able to see live everything. If you are in the film industry, you will understand how difficult it is to generate real-time 3D visual and audio content, such as this kind of particle effects, the air, the reflections. And maybe in the future, if you go to see a VR film, or when you get inside this VR film, you will be able to see your own reflections. But now we are highly depending on supercomputer, and VR device is still very expensive. And in the future, all you need is just go to a web browser, and then you can get inside this kind of virtual world. Let's say Markus, he develops tools to enable us to see real 3D artwork. You don't have to go to New York. You don't have to go to London. All you need to just go to the museum website. You can already see the very realistic, real 3D scan of the artwork. This is the future of the technology in terms of artistic practice or artistic applications. And of course, I can talk a lot more about the other applications for mental health. But so far, this is how I can see it. But remember, we have a very short time for this project. We have only 2 months to develop with a very small budget. This kind of artwork or this kind of work normally would take 20 people to do it, and it requires much longer time frame, such as at least 2 years to develop the basic code. So anyway, I can see a lot of possibility in terms of this kind of art and technology in the future. But I now let Markus share his perspective.
Yeah, thank you both. Yes, and there are a lot of interesting questions in chat box. And some of them are actually covered in the response from Soo-young and Markus. And
Yes.
I see that Sammy asked, how do you see the difference between a film and a web installation? Maybe this time Markus can respond first.
Yes. Well, almost like a traditional, film versus animation sort of perspective, right? In film, usually the way you work on it, right? You do a lot of pre-visualization, and then you go in and you block the actors, you block the scene, and you have basically you can take multiple takes with your camera in a certain position, but then after that it's done, everybody else is gone, right? This talent is gone. It costs a lot of money. All the crew costs a lot of money that's constantly being there to film the scene. So you're pretty much set with what you sort of pre-visualize and do. Versus in animation, I mean, it also costs a lot of money, but you're a lot more flexible in that way because you can reiterate, you can change the talent, you can replay the scene from this angle, you can change the camera over here, you can you can slow down the camera, you can change your effects constantly and tweak it every little bit. I mean, for that reason, I think all those animation films you see, they're always so polished because they have so much time and care that they can put into it. Versus, on a traditional film, you have like 3-4 months and that's it. And then you're done with the physical filming, and that's all the time you have.
Yeah. This is actually very good questions about the challenge of an artwork presenting in a web browser. This kind of art form is quite new, presenting artwork in a web browser, and it's not only because of its technical or artistic challenges. For me, when I was working for this artwork, the biggest challenge is that online artwork is actually challenging our perceptions on how we recognize art and internet browser. Because we're very used to understand that artistic experience comes from going to museum, to theater, to cinema, or art gallery. How we recognize something we think it's art, it's not only the artwork itself, it's also about where and when the artwork is presented. Meanwhile, we have to understand that we have been using internet browser for the last few decades as the source of information and entertainment. So if now I tell you by visiting a website, it's replacing your experience to go into a museum or a gallery. This is quite new concept for many of us because our collective perceptions on what art is or where art should be being exhibited, it has been very restricted to physical venues for many years, such as going to museum, gallery, theater, or cinema. So this kind of physical venue associate how art is being presented. So this is for sure is a very new culture for us. art being presented in a web browser. But it will still need some time for us to renew our perceptions when, where, and how we experience art.
A question from both the Facebook and also in our chat is that apart from the 3D modeling for visuals, how about the music or audio parts be integrated into the virtual reality, as many VR devices or glasses may have also built-in enhanced sound effects for immersive or cinematic experience?
So for virtual reality and sort of 360-degree environments, like even even in a movie theater these days, with Dolby Atmos, you have sound technologies that are called spatial audio. But the general idea behind them is that you can discern every single element of the audio, where it's coming from and at what height the audio is coming from. So let's say you have an orchestra, like a really bombastic piece. You could hear the violin is coming from like 40 degrees behind you from this height on the back of your ear, right? So I mean, you could really sense where the music instruments are situated in the room, and as you turn your head, it will sort of follow that logic, right? And when you turn around and you face the violin, it will come from the front. You know that the sound follows the sort of positioning of the viewer in the virtual space. Yeah.
Thank you. So there is a question from Eve. It's about the future of arts, mental health, and also technology. Because I think because this project, you also integrate mindfulness and also contemplative art into your project. Possible collaboration be like?
The question about art, mental health, and technology, what would be the collaboration be like? This is actually a very good question, and this is also why I do my presentation this time. Because I believe in cross-disciplinary collaboration will bring into a lot of impact in between arts and mental health, arts and science, and arts and technology. However, this kind of collaboration is been happening everywhere. We can see web-based or app-based tools for stress reductions, and these become more and more common. This kind of non-pharmaceutical interventions are getting more and more recognized by the medical world. You can download apps that come with soundscape or music or audio-visual content that are specifically designed for you to calm down or practice meditation, are become more and more common. As an artist, I'm very happy to see the art world and the medical world can create more cross-disciplinary collaborations because we can combine our expertise and come up with new strategies to create tools or artworks that could benefit to both mental health, arts development, and cross-disciplinary education. But this kind of future development is highly depending on institutions, because people from different disciplines are very depending on this kind of platform to work together and to brainstorm and to incubate new ideas. So I think it's very important for commissioners, for universities or festivals or arts organizations to create more platforms for artists, technologists, or people in the medical professions come and work together, incubating new ideas, try new prototype, because this would bring new possibilities between art and mental health when these people come together, and then they really can work together. And this is where the moments art and mental health will be able to flourish.
Thank you both. So I can see we are on time, and thank you so much for all who participated in this forum. And it's a very, as many said, as a very insightful and inspiring sharing. And I'm also excited as a drama therapist to see all the cross-disciplinary collaboration and future development of this kind of ACT project. Thank you both, and thank you all of us. Wish you a great night. Good night, everyone.
Thank you. Thank you. Good night.
Thank you. Bye.
Bye.
Bye.